So question 14 tells us about a cylindrical tin. So we'll just sketch that. And there's a rectangular label glued on with a bit of an overlap. And they want us to find the dimensions of this label. Now they want us to find that in millimeters. And when you look at the question, there's a mixture of measurements between centimeters and millimeters. In any question, it's always better to choose one unit and go with it. And in this one, because they require the answer in millimeters, it makes the most sense to work the entire question in millimeters. So we're told that there's a radius of 4 centimeters, so that's 40 millimeters. We have a height of 12 centimeters, which is 120 millimeters. There is a 15 millimeter gap above and below the label, and a 10 millimeter overlap. So the label is wrapped around the cylinder. We are told that it's a rectangular label, so if we want to just draw it out, so we have our 10 millimeter overlap. Our height or width of the label, depending on which orientation you're talking about, is going to be our 120 millimeters minus the 30 millimeter gap, which gives us 90 millimeters for the width. And this particular measurement, the length, will be given to us by working out the curved surface area. So the reason we use the curved surface area is because the label is wrapped around the curved surface of the cylinder. So the CSA, curved surface area of a cylinder, is calculated using the formula 2 pi or h. So we have 2 pi, and we weren't given a measurement for pi, so we just keep it as it is. 40 millimeters for the radius and 120 for the height. So we then have 30159.28947 millimeters. Okay. Now, the reason we use the 120 and not the 90 is because we're getting the full curved surface area of this cylinder, not just the label part. So we take the whole lot of that. So that's giving us the area, okay? So that's the area of, it's the curved surface area of the cylinder, but it's the area of the label as well. Okay, we take this, so 30159, and we divide it by 12, because if we had been just finding the curved surface area of the tin, so if I just sketch it out here, so let's say this is the tin, right, and we have our label there. This entire area would be given by, sorry, that's 120, by our 120 times this length. Okay, and that entire value is the 30159.28947. So by dividing this value, this area, by the 120, we're going to get the length of the entire curved area of the tin, which is the same as the label, and that's how it corresponds. So when we divide that in, we get 25 251.3274123. We must then add on the 10 millimeters of the overlap. Okay, so this bit here is 251.3274123. We add on the 10 millimeters of our overlap and we get 261.3274123. They say in the question they want it to the nearest millimeter, so that's approximately equal to 261 millimeters. So finally, our length, 261 millimeters, and our width, as calculated at the very beginning, 90 millimeters.